Hello and welcome to another video. We're going to be continuing on with the blind 75 in Typescript, and we're going to be doing combination sum. So in this problem, you're given an array of distinct integers and a target, and you want to return a list of all unique combinations of candidates which are add up to the target, and you can return them in any order. And the numbers, I believe, can be any order as well, but you don't want to have duplicates. So what you want to have is, like for this example here, for this 2, 3, 6, 6, 7, let's say 2, 2, 3 does add up to 7, you don't want to have something like 2, 3, 2 as well, right? So you don't want to have something like that. And this is kind of similar to coin change, essentially, but now we're basically asked. So this is actually, if you think about it, this is actually pretty much the same as coin change with a little bit of rewording. So if asked, in coin change, there's usually two problems, right? Return the number of ways I can add, like the number of combinations I can have to get some target, or it's usually going to be like return the minimum number of coins I need. Well, this is like that third version of, well, instead of returning the minimum number of coins, give me arrays of all possible combinations of coins that add up to some total, right? And that would be basically like coin change. And there's a few ways you could do this. It turns out you could do this with backtracking, but we're not going to do that. I think that this is like backtracking is like kind of like the default option, and I think that is the explanation on LeetCode, and that's the main way people do it. But because this is in TypeScript, I wanted to do something different, so we're actually going to use dynamic programming instead. And so the way this is going to work is, first of all, let's go through these examples. So for this 2, 3, 6, 7 to add up to 7, so if you think about it, there's only a couple ways, right? So it's going to be 2, 2, 3, and then just 7. And those are all the combinations. And then for the second example, for 2, 3, 5, once again, just thinking about it logically. So 2, 2, 2, 2, and then we have 3, 5. Right, I think that's it. Oh, we have 2, 3, 3 as well. Okay. And then for this 2 add equals 1, you can't do anything. So that's just going to be nothing. Okay. So let's think about, for dynamic programming, kind of like, for dynamic programming, you need 3 things, right? So you need parameters, you need a base case, and then you need a recursive case. And let's think of all of these things, and let's figure out how we could actually do dynamic programming here. So we have parameters, a base case, and a recursive case. Okay, so for the parameters, like what things do we need? Well, let's think about what we needed in coin change typically. If you haven't done coin change, or if you have, it's going to be kind of similar. So you need 2 things. Let's actually change this maybe to a different color. Yeah, so let's do that. Actually, oh yeah, there we go. Okay, so let's change this to, yeah, that's good. Okay, so for parameters, let's just write them down here. And yeah, let's, I guess we can have the same color, it's fine. Okay, so we're going to have, why is it in Russian? Oh yeah, because I think I changed my font. Okay, there we go. So for the parameters, we're going to have a couple things, right? So we're going to need the index of the current element we're on, because I'll talk about how you avoid duplicates. And then you actually want to have the target you have left, right? So just like in the coin change, this is kind of similar where you have a target and an index. Okay, index and target, and there we go. And so the way to avoid duplicates is, what we're going to do, just to like briefly describe it, is at each point we have 2 options. We can either use, so let's just like draw this out a little bit down here. There we go. Okay, and we are trying to get 7. So at each point, at each index, we can either use the number or we can not use the number. If we use the number, then we just shrink our target, right, by whatever number we have. So let's say we use 2, then our target would turn into 5. And if we don't use the number, then we can move on to the next number, but we can't go back. So if you're done using 2, you can't go back and use 2 again, and that would help us avoid duplicates. So that's that, but I'll talk about that in the recursive cases, but that's going to help us avoid that. Okay. Now we're going to have a few, yeah, so these are our things. It's like our index and the target you have left. Okay, so let's write down our base cases. So there's going to be probably a few. So for one, index is out of bounds. So if that's the case, if the index is out of bounds, then what would we want to do, right? We would want to return an empty array because there are no solutions there, right? Like if the index is out of bounds and we still have a target, we don't want to do anything there. Okay, now there are a couple more. And so another one is, let's think about, so what we're going to also do, by the way, is we are going to sort our numbers to make this easier. Just because the dynamic programming solution is going to be like n squared or something really big, so sorting is basically free. So our numbers are always going to be in increasing order. And so if the number we're currently on, so if number we are on is less, is it less than? Yeah, it has to be less than. Actually, no. If it's less than, it's fine. So if it's greater than the target, then what do we want to return, right? So let's say we have some sorted numbers and we're on this number here and our target's like 5. Well, we can only use these numbers. So obviously if we're on this number and we try to get a 5, we can't do that, right? So if the number that we're on is greater than target, we also want to return the empty array. And then can we think of anything else? So there is another one. And you can obviously clean this up, but this is just the way I'm going to do it. So if the number we are on equals the target, then we want to return an array. So it needs to be a nested array, right? Because as you can see in the output, it's nested array. So we're just going to return a nested array with just target here, right? And that makes sense. Like, let's say our number we're on a 6 and we're trying to get 6. We would just return this as our number of ways to get 6, right? Because these numbers are increasing, so anything past this number isn't going to work, and they're also unique. They're guaranteed to be unique. Okay, so there's that, and then there's also, let's think of anything else we missed here. So we also have the cache, obviously, right? So cache is also another one where we just return the cached value. Okay, but that's it for that. Now let's think of the recursive cases. So at each index, we have two choices. A, use the number. And what would we do there if we use the number? So then we have to add the number to the array from, and then what's our like recursive case? So it's going to be dp of, if we use the number, then our index stays the same, but our target goes down, right? So minus that number. And so let's just see what that's going to look like, right? So in this example, like let's say we are in 2, 3, 6, 7, and we have 2, 3, 6, 7, and we are on number 2, and our target is 7. So if we end up using 2, we have to say, okay, we need to append 2 to the result of this 2, 3, 6, 7, and now we're looking for a 5. And we are on 2. And what would that look like for this 2, 3, 6, 7? So this part would return, like if you think about it, what are the possible solutions? It's only 2, 3, right? So essentially we'd have something like this, and then we'd say for everything in this array, append a 2 to the front. So we would say, okay, there's a 2, 3 at the front. Actually, we can append to the back just to make it, because like we don't need to append to the front because you don't want to append to the front of an array. We can append to the back, like the word doesn't matter. Okay, so we're going to have 2, 3. Well, it's actually going to be 3, 2. It's going to be backwards because we're appending to the back. But yeah, so we are going to append this 2 to that and then return, right? So that's what we have to do. And if there's more things here, then we have to append this 2 to every single thing in the array, because essentially this will be an array of all of the numbers that add up to 5, and then you just add a 2 to all of them, and then that would make it 7. Okay, so that's one case, we use the number. Then the second case is we don't use the number. And if we don't use the number, all we have to do is increment the index, right? We're not gonna like have any other stuff, but we need to do one more thing. So then we need to add the array, we need to add the array of results from dp index plus 1 target into the result. And what I mean by that is, like, let's say we have a result, and for this 2, 3, 6, 7 again, we're looking for 7, and we're on here and we say, oh, we don't want to use it, whatever. Now our new state is going to be this, and so this whole thing is going to end up returning just an array like this, and we need to say, for every single number in here as well, let's add that to our result, but we don't have to like add anything to it, because that's going to be all of our cases where we don't have the number. And so these are both of the things you have. So when you use the number, all of your cases will have that number plus every single array in the result. And then if you don't use a number, you also need to take every single array in the result. You need to combine both of these, and that's going to be your result. And then finally, we just cast the result and return the result. And so yeah, so definitely with the dynamic programming, it's a little bit trickier than backtracking, but it's good to try. And we are also going to run into TypeScript things that are going to that I wanted to show that are definitely really interesting. There's going to be some JavaScript stuff as well. I guess it's both JavaScript and TypeScript stuff that you might not have seen before. And so it's definitely going to be interesting to learn. Okay, so let's get into the code. So what we actually need to do is we need to make a cache, right? And so if you think about it, for our cache, let's actually go back to our picture. So for the key for our cache, it's going to have an index and a target, right? And then for the value, it's going to be an array of arrays. So that's going to be kind of interesting to do. And so let's think about how that would work. So we need to make a cache. So it needs to be, the key is going to be a string. So the way to do this, by the way, so if you have a cache, there's a few ways to do this. You can make an object type looking for specific things. But if you just want an object with keys of some type and values of some type, you just want to do this record, and then you provide the two types. So you could say we want the key to be a string, and we want the value to be a number. We need to be a nested array, right, as a result. Okay. And we're just going to make that equal to an empty object to start off. Because, yeah, this combination sum is expecting a nested array. So we're going to make this cache, and we're going to use it. We need to make one other thing. So in Python, when you have something like this, and you have an index and a target, right? So let's say you have index and a target, you can just like pass that tuple up into the dictionary key, and it will like do stuff for you because the tuple is immutable, and it will like work. But in JavaScript, we can't really pass. You can't pass an array into, like, you need to have a string. So then what we need to do is we need to actually stringify our key, and then we can use that key to like to use that key for the dictionary. And so we're going to make a helper function here, and we are going to make that right now. So it's going to be like const, call it cache key. Then this is going to be our function that's going to actually like stringify our key for us. So it's going to take an index, number, and a target that's also a number. And we just want some way to stringify like all this together, and it's pretty straightforward. We can just make a template literal, and we can just say like, okay, let's just take the index, stringified, and then we will add like a little dash maybe, because we want to have some kind of separation character between the index and the target. That can't be a number, right? You don't want to just like add them together, because if you had some numbers that are like let's say you had 90 and 90, or also you had 909 and 0, that would, if you just add them together, they would give you the same string. So you want to make sure to have some kind of separation character there. Okay. And then we want to have target here. So that's just going to give us like a string result essentially. Okay. And so now let's think about what else we need to do. So remember, our numbers weren't necessarily sorted, and our algorithm relies on knowing that like if you're at some number and that number doesn't work, every number past it won't work because they're all bigger. So we actually need to sort them. But notice, and I'm just going to write this, I'm just going to show a basic example of, like, let's say we have some numbers like 1, 2, 5, 6, 15, 19, 25, whatever. So if we just do this and we just do dot sort, like if we just say this, so const nums equals this, and we can just do like nums dot sort, and we can console log that. Let's see what happens. I don't know if this will actually run because we do have some errors. Maybe we can just comment this out for now. Let's do that. So you can see it like doesn't make any sense, right? Our numbers weren't in the order we expected. So the JavaScript default sort method actually converts your numbers to strings and then compares characters. So 1 would come before 15 because that would be like A coming before like AC or something, But then a 25 comes before 3 because 2 is less than 3 in string. So that's the problem here. And so what we need to actually do is we need to make a sort, but we need to make a custom sort function, and it's pretty straightforward in JavaScript. So you can just say candidates.sort, and then you have to give it a function. So you can just say like AB, and then what you have to do is you just say like what's the thing you want. And so if you want A to come before B, then you need this function to be negative when A is smaller than B. So the way we're going to do that is like this. Now, if you think about it, like if A is 2 and B is 5, this would be negative. And then if A is 5 and B is 2, that would be positive. So that's what you want. If you want A to come before B, this needs to be negative. And then, yeah. Okay. So that's how we sort. Now we kind of have everything we need to actually do our DP. So let's just make a function. Let's make it, we can do a const as well. The DP, and then it's going to be a function that's going to take in an index. It'll be a number. And it's going to take in a target. It'll be a number. And then we want to return a number array. Okay. So the first thing we need to do is actually get this key. So we're going to get this key by using this cache key. So we can say const key equals cache key. And we are going to give it the index and the number. So that's going to, this needs to be target. Now we can actually get the key. Now we need to check if we can check for the cache situation first. So we can just say like if key in cache. There's a bunch of ways you could do it, but this is fine. Okay, then we can return cache key. You could also do if cache key. There's a bunch of ways you could do it. You do have to be careful like moving up the prototype chain, but I think for something simple like this, it's not a big deal. Okay, so then let's look at our other base cases. So remember our base case is if we're out of bounds. So if this is like this, candidates.length, or candidates index is greater than the target, right? And so because our numbers are ascending, so if we have like 1, 2, 3, 4, and so on, like let's say we're at 3 and our target's 2, we know that anything bigger won't work either. So if at any time we're at an index that's bigger than the target, we can just return false right away. Okay. So if candidate's index is greater than the target, then we need to, I don't know why it's giving me a thing here. I'm kind of curious. We'll see what happens there. Okay. Yeah. So let's figure that out. Okay. So in here, we just need to return the empty array, right? Because essentially, I think that's just the color for greater than maybe. Okay. So yeah, like we need to return the empty array because this means that these are invalid, right? So what else do we have? So we have a match. So if index, or if this is going to be candidates index equals the target, then we have a match. And you do, it's, at least for me, I found that it's like you need more test cases because it's kind of tricky what you want to return. Like let's say your target is 0 or something. It's kind of tricky what you want to return. So I just found it was easier to make the match here as opposed to like in coin change where you can just check for 0 later on. Because you don't want to return an empty array because you're checking for all your outputs in previous returns. But we'll get into that. Okay, so if this is the case, then remember we want to return the target. But remember, it needs to be a nested array, so we need to do this. Okay, now we need to actually get our result. So we can say let res result equals a, and it's going to be type number. So here, because our result is an empty array, you do want to specify the type. Like if you made your result like 1, 2, 3, and you're like, okay, I know my result's going to be a number, then you don't really need to give the type. But because it's an empty array, it can be like any type, so you want to give the type. But if you just set it equal to something that's like undistinguishable, or you know, like if you set it equal to 5, you don't need to say it's like a number as well, because that'd be redundant. But because you made it an empty array, you definitely want to set the type. Okay. And so now what we need to do is we need to include the current candidate, and then we need to find the combinations for the remaining target. So what would be like including the current candidate look like? So we could say, let's see. So we want to actually get this result, right? So we want to, let's just call this like dp res or something equals dp of index. And this is going to be, we want to save this because we're going to be looping through it. So we might as well just save the variable. So target minus candidates index. And so this is the case where we did end up using that, number, right? And so we need to loop through here. So we need to say let item of dp res. And we need to say, we need to push that onto the result. So we need to do res push. And then remember, you need to add the item with the actual index you're at, right? So if your output here was like this, let's say like it's like 1, 2, and that was like 2, 5. Obviously these are wrong, but just an example, 3, 6. And then our number was 2, we'd want to push 2 to all of these, right? So we'd want to push 2 to all of these, and then this would be our new result, essentially. So that's what we're going to be doing. So we're going to be doing res.push, and then we're going to be doing item.concat, because we're essentially taking the old thing, and then you want to do candidates index. Okay. So you're essentially concatenating it with the candidates index. Yeah. Okay. You can also do like a split if you wanted to, but either way, this works fine. Okay. So now what we need to do is we have that case, but now we have the other case where we don't have, like we didn't use a number. So we can reuse dpres again, and we can say dp. Okay, if we don't use a number, then the index goes up by 1, and our target stays the same. And then we do the same thing. So for let item of dpres. So now essentially we need to make a copy of every single item, and so because if it gets changed, like we want to make sure we want to make like a unique copy. We don't want to just like take that one. So we can do res.push. Then we could slice here, or you could do something like this. There's a bunch of things you could do. Well, we're just going to use a slice, so because that will make a copy. Okay, and then we need to actually cache our dpres or our result, right? So to do that, we need to do cache, and then we made our key up here, so we already have it, equals result, and then finally return the result. Okay, and then so now that we have this helper function to do everything, what do we need to actually return? Well, that part's pretty straightforward. We just need to return that function being called on index 0 with a target that's this target that was passed in here, right? So we need to call it on index 0 with target. Okay, and now we can actually test some of our stuff. So let's go back and look at our picture and see what we have. So we have 23677, 2358. So let's try some of those. So we can console log what the... Okay, so we can console log. Okay, so we do have an error here still. Well, I guess we'll see. Okay. I guess it's saying line 8. Oh, right here. Oh, it expects an error. DP. Oh, right. Yeah, we didn't give it an error like for the return, I think is the problem. Yeah. Okay. There we go. So console log. We need to 1, 2, 3 or 2, 3, 6, 7, I believe, and it was 7. And we can give 7. And we need to actually call our function, obviously, right? So it's going to be combination sum. Okay. And yeah, so that did work. And if we try like 8, that also worked. As you can see, we tried 9. That also worked. And what if we try a number that doesn't work, like 1? We get an empty array. Yep, 2, 3, 6, 8. We try to get a number like 4. Works. A number like 3 works, 5, and so on. Yeah, so I think we're good. So let's see what happens when we send that up to LeetCode. I don't think I have an export here, so I think we should be good there. Okay, let's see. Okay. Okay, so it looks like it does work, and like I said, this stuff is kind of like, it's all over the place. It's also really hard to calculate time complexity with this one, but let's try to do that. Okay, so let's try to figure out the time complexity and the space complexity here. So for the time, if you think about it, how many states do we actually have? So we have index and we have target. So we can just say, let's just say index is like length of the candidates, and then target is the target. So that's going to be like already, I mean, technically you won't have like, you won't have every single target possible because it depends on the array, but let's just say worst case we do. So it's going to be like index or length candidates. So this is going to be like O of n, where n is the length of candidates, times t, where t is the target. And so what are we also doing here, right, as far as like this other stuff? So sorting costs us nothing, making cache key costs us nothing. But we do actually have to go through the results every time, like, right? We're just looping through our results. So if you think about it, for our results, how many total combinations can you have? So you can have 150 combinations. So that's like 150 there, because you're looping through all of them. And then you are also basically making a copy of each combination. So I don't know what the length of a combination is. I don't know if it tells you. But essentially the length of a combination is something along the lines of target, like the biggest combination you can have is target minus like smallest number or something, right? Because like if our target is 6 and our number is 1, then the biggest combination we can have is like 6. So it would be somewhere along those lines. But you can see these numbers are relatively small, so that's why it works. Like this is only 40. This is only so yeah, this is only 40. Target's only 40. Yeah, so this is only like 40 as well. So it doesn't end up being that big. But yeah, that's essentially it. Like we're looping through all our stuff, so we have to figure out like how many items did we loop for, and then how long is each array, because we're actually making a copy of it. Okay. And for the space, and yeah, also if you did backtracking, it would also be like a confusing calculation. These are always the like most confusing calculations for all these things. Okay, so for the space, we do have the same kind of thing, number and target. So that's going to be number and target. And then we have to figure out essentially how big is each state, right? Like for each of these states, how big is the array essentially? And so if you think about it, that's kind of similar to where you have 150 combinations, right? So you can have 150 combinations in each state here. And then how many items are in each array, and that's going to be the same thing, t over smallest number. It's going to be something along these lines for the space and time. Yeah. And so I think that's going to be everything for this problem. Hopefully you liked all these new things. And yeah, it's definitely kind of interesting to learn how to make key and things like that with a tuple instead of a single number. It's a little bit less straightforward. And if you guys do have like maybe a better way of making a tuple, like I haven't really done this too often, this is just one way I found that works, you can let me know in the comments. And yeah, if you did like the video and you did, yeah, if you liked the video, just like the video and subscribe to the channel. It'll help grow it. And I will, as always, upload this to the GitHub that you can get all of the other problems from. And I'll see you in the next one. Thanks for watching.